Hello, hello. Namaste, one and all. My name is Arjun Joshi from Electrical and Electronics Engineering. In this video, let's we discuss about design and analysis of operation amplifier based Schmitt trigger under both configuration, like inverting configuration and non-inverting configuration. Okay. Before getting to the actual calculation, I'm going to show you the theoretical concept how our Schmitt trigger will going to work. Okay. Now, this is nothing but our Schmitt trigger circuit diagram. Here, as per the as name suggests, inverting Schmitt trigger. Inverting Schmitt trigger is nothing but here I'm going to give input signal generator supply to the inverting terminal, as you know. Okay, and then I'm going to give the non-inverting terminal to the biasing circuit like R1 and R2, between R1 and R2. R2 across R2, the voltage, one voltage will going to generate, the voltage drop will going to generate. That voltage drop will going to, I'm going to refer that one as reference voltage, or UTP plus UTP or minus LTP. Okay, this is how I'm going to build a circuit. What is the uniqueness of this circuit? Irrespective of input sine wave, irrespective of the input sine wave, waveforms like sine wave, triangular wave, pulse, sawtooth, anything, the output should be rectangular like this. Okay, yes. And then what is the explanation of this waveform? Very simple. We need to consider first, you need to write one sine wave from 0 to 360 degree. Okay. And then you need to mark one dotted line in the 0 line, and then positive reference. Positive reference is nothing but UTP, and then negative reference is nothing but LTP. Then you need to mark one rectangular waveform that should intersect with the input, that is nothing but UTP. Okay, UTP, and then come left, draw here, and then this is nothing but LTP. You can stop here only, or you can rise from negative to positive. And let's understand clearly. Okay, what will happen means, before input reaches this line, okay, this UTP, this mark intersect, okay, intersection, the output is in positive only. What is the circuit here? Inverting. It should give 180-degree phase shift, means input positive, output should be negative. But here what will going to happen before input reaches this UTP? Output is also positive, input is also positive. This is not the characteristics of our inverting, but here there is a reference those, so that's why our inverted Schmitt trigger is remaining positive only. Once our input reaches UTP, the output will going to change from positive to negative, positive to negative. Here our output continue up to our input reaches LTP. Whenever our input reaches LTP, output will going to change from negative to positive saturation. Okay, this is how our inverting Schmitt trigger will going to work. Okay, here we have two triggers. Okay, first one is UTP, upper threshold point, and then lower threshold point, or our upper triggering point, or lower triggering point. Okay, this V positive VR2 is nothing but UTP, minus VR2 is nothing but LTP, means VR2 is nothing but reference voltage, positive reference, negative reference. Okay, you need to apply voltage divider rule across VR2 equal to V0 into R2 divided by R1 plus R2. VR2 is nothing but UTP equal to plus V0 saturation, R2 divided by R1 equal R1 plus R2, and LTP equal to minus V0 saturation, R2 divided by R1 plus R2. And then design, you need to apply Ohm's law across through the R2 equal to UTP or triggering voltage divided by I2. I2 is nothing but 50 microampere. You know the explanation of I2. Okay, and then I2 equal to 100 into IB max. Okay, IB max is nothing but 500 nanoampere. 100 into 500 nanoampere equal to 50 microampere. R1 equal to V0 minus triggering voltage divided by I2. Okay, and then this is nothing but hysteresis curve. You can elaborate this hysteresis curve with the help of your input and output waveform. Before our input reaches this UTP output will going to remain in positive only. Whenever our input reaches UTP, the output will going to change from positive reference to negative reference. And then whenever our input reaches LTP, our output will going to change from negative to positive. And it will going to remain in negative only until our input reaches LTP. Whenever our input reaches LTP, output will going to change from negative to positive. Okay, this cycle will going to continue. Okay, yes, this is nothing but our lysogeus or hysteresis curve. Okay, we get into the problem, our practical problem. What is the problem here? Design a Schmitt trigger circuit for a triggering point. That is nothing but positive 2 volts, UTP 2 volts, LTP 2 volts with sine wave input with 4 volts peak value and 1 kilohertz frequency with supply voltage plus or minus 12 volts. Here they are going to mention frequency, peak value, triggering voltage, and then plus or minus VCC, VE 12. Okay. R2 equal to UTP I2. Substitute here UTP. What is that? 2 divided by I2, 50 microampere 40K. R1 equal to V0 minus UTP divided by I2. V0 is nothing but what is the V0 value? We don't know V0 value. How to calculate? They're going to mention 12 volts VCC. We know VCC 12 minus 1 equal to 11 plus 11. Okay. Plus 11. Okay. And then 11 minus UTP2, 11 minus 2 divided by 50 microampere, 180 kilo. Okay. Now I'm going to simulate the circuit like this. Very simple simulation. I think all of you know how to simulate the circuit. We need to take the component from the place component, 741 IC, VCC, VEE, VCCV, ground, oscilloscope. We can take from here only oscilloscope function generator, and then oscilloscope. Everything is remaining same. We can how we can rotate this circuit. We can use this flip vertically, horizontally. You can change. Okay, you can saw the circuit diagram and build the circuit diagram. Okay, here. Okay. Now I'm going to set the function generator input 1 kilohertz and VP equal to 4 volt peak. Okay. Now I'm going to run. Yes, output will going to come. Hold on. Just we need to check input and output first. What is the input value? 4 volts peak. Just kept it in the minimum position T2, T1 in the maximum position, and check here. Yes, 4 volts peak is nothing but 8 volts. Okay, you need to keep it in the exact position. That will going to show exact value. Okay, 7.94 exactly correct. Input equal to 8 volts, output equal to 22. That is nothing but plus or minus 11 volts is nothing but 22 only. Plus or minus 4 volts is nothing but 8 volts only. Plus or minus 11 volts equal to 22 only. Okay, and then this is how we need to check input and output waveform, and then write down here input write theoretical value. What is theoretical value of output? Plus or minus 11 volts plus or minus 11 volts. Output equal to plus or minus or directly 22 volts or plus or minus 11 volts. Both are same. Okay, here also theoretical 22. Here 22.22. Okay, and then UTP LTP. How to check UTP LTP? Just keep this intersection point. Yes. What should be the expected UTP LTP? 2 plus 2 minus 2. Okay. Here 2.1 is the plus minus 2.4. Okay. You need to take down the reading here. Theoretical value 2.1, 2.5. Okay. You can take like that. Okay. Yes. Now I'm going to show you the hysteresis curve. Just kept as it is, and just click on B bar A. Now I'm going to check the UTP. This is nothing but UTP. Okay. How to check UTP? Go to the reference waveform or a reference graph. This is nothing but UTP. This is nothing but LTP. Okay. Like that. UTP into 2. UTP is nothing but here the boxes are covered. 1 box into 2, 2. Here also 1 box into 2, 2. Okay. UTP equal to 2. LTP equal to 2 as per our design. Okay, this is how we need to check our Schmitt trigger. Okay, Schmitt trigger output. Now I'm going to show you the non-inverting Schmitt trigger. What do you mean by non-inverting? Here I'm going to give the input signal to the non-inverting terminal. Okay, what is the design here? Design here, very simple design here also. Okay, very simple. plus or minus triggering points plus 0.5 minus 0.5 to produce output. They are going to mention the output plus or minus 14 volts. How we can extract the output input from the output? V0 minus 1, 14, sorry, plus 1, V0 plus 1, 14 plus 1 is nothing but Vi. Okay, that is nothing but Vi equal to 15. Okay, now I2 we know 50 microampere, R1 equal to VR1 divided by I2. VR1 is nothing but VR1 is nothing but 0.5 UTP, 10 kilo. V0 is nothing but 14. 14 divided by I2, that is nothing but 280. Okay, now I'm going to set the input to 7.5, that is nothing but plus or minus 15 volts. Okay, 1 kilohertz, close and run. Okay, here what is the input? Plus or minus, so total 14, 14.5, sorry, 19 alva, 14 plus 1. Okay, 14 plus 1, nothing, that is nothing but 15. Here output shows input as per the multisim 14.9, what is the output? 28. Okay, 28 is nothing but plus or plus 14 minus 14 as per this, plus 14 minus 14 here exactly plus 14, that is nothing but 30.7 minus 14 as that is nothing but total 28, that is nothing but plus or minus 14 only, exactly correct. Okay, how to check the UTP and LTP? Yes, UTP kept here, run another one time and hold on. UTP, LTP, okay, approximately 1.8, 1.1. Actually, it should, so it should give 1. It should give 0.5, but it gives 1. Here also 0.5, but here 2. Okay, sorry, 1.8. Okay, it's okay. Okay, yes, this is how we need to check the input and output waveforms and LTP, UTP in the graph sheet, in the multisim waveform as well code, and then hysteresis curve like this, correct? What is the value here? 0.2 into 5 is nothing but 0.2 into 5 is nothing but 1. Okay, here also 0.2, 0.3, 0.3 into 5, 1.5. Okay, as per our exactly correct, like this only. Okay, thank you, one and all.